How large must an electric field be so that the force on the electron is equal to the electron's weight? Alright, so in this problem, first step would be to create a free body diagram. Alright, and in this free body diagram we're going to have weight, the force due to gravity, going down, and we're going to have the Coulomb force, F sub c, going up. Now this force is equal to QE. In this case it can also be equal to KQQ over R squared. Alright, so we know that it has the sum of the forces have to be equal to 0, so we can say that the gravitational force is equal to the Coulomb force. Mg is equal to QE, and solving for E, well, let me put some constants here first. The mass of the electron, 9.109 times 10 to the negative 31st kilograms. Charge on the electron is 1.602 times 10 to the negative 19th coulombs. And K, I may be getting K here. Alright, anyway, solving for the electric field, we get that it's mg over q. mg over q. Which is equal to 9.109 times 10 to the negative 31st kilograms times 9.81, or 9.8 meters per second squared, all over the charge 1.602 times 10 to the negative 19th coulombs. And whenever we solve this, we get 5.5723 times 10 to the negative 11th newtons per coulomb. Alright, let's see if this works. See if Mastering Physics likes this. And just to demonstrate, we know that the force, the weight's going down, and this is a negatively charged particle. So the electric field is for a positively charged particle. If it were going down, a positively charged particle would go down, thus a negatively charged particle would go up. And that creates the force that counteracts the weight. So the electric field in this case will be going down. Oh, yep, looks like that was correct. That's always a good thing. And so we now start on the next one. How far away from a proton would you have to go for its electric field to have the value in part A? Basically what it's asking is what is the electric field at a certain point has the value of 5.58 times 10 to the negative 11th whenever you're so far away from a proton. Alright, charge on a proton is the same as the charge on the electron, it's just positive, where an electron is negative 1.602 times 10 to the negative 19th. Whenever I do my calculations, I don't really put in the negative signs for any of my Q's. I go in afterwards and use the physical understanding that I have to then determine which way the force will be acting. Alright, so the electric field that we have to find is 5.572 times 10 to the negative 11th. E, or K, is 8.99 times 10 to the 9th newtons per meter squared, or newton meter squared per coulomb squared. Alright, and we know that the formula for the electric field is KQ over R squared. So if we solve for R squared, we get that R squared is, or ER squared is equal to KQ, R squared is equal to KQ over E, therefore R is the square root of the quantity KQ over E. Now we plug in some numbers here, and we find I'm going to go ahead and put in the units here and just go ahead and show you how they all cancel. Let me just go ahead and put this in right quick. Yeah, 5.572. Alright, so as you can see, we can cancel our newtons, and then our coulombs cancel. Coulombs cancel again. We're left with meters squared. So R is equal to all these numbers, 8.99 times 10 to the 9th times 1.602 times 10 to the negative 19 divided by 5.572 times 10 to the negative 11th meters squared, and take the square root of that quantity. You know, if you take the square root of meters squared, your units is meters, and that's what we need them in. Let me punch this into the calculator right quick. And I get that the radius is equal to 5.084 meters. And let's put this into Mastering Physics. Submit. Hey, there it is. And that's problem 17.38.